MCAT 2015 Cram Physical Foundations question. Flashcard 17. Tension in a clothesline. All right. 3 kilograms of wet clothes are hung on the middle of a clothesline with posts 6 feet apart. The clothesline sags down by 3 feet. What is the total tension upon the clothesline? Is it going to be A, 30 radical 2 newtons, B, 60 radical 2 newtons, C, 15 radical 2 over 2 newtons, or D, 15 radical 2 newtons? Now, this problem is not that difficult, but you do have to take into account both components, both sides of the line. So I'll just give you a moment to set up your equation and to solve for the total tension, okay? Definitely press pause if you need to. All right, let's get into the solution. Okay, so the clothes are hung in the middle of the line. This means that we can treat the horizontal portion of each triangle that's formed as 3 feet, okay? And the lines, obviously, that are sagging down have a height of 3 feet. So, in effect, what we have is an isosceles right triangle, 2 sets of them. Let me show you what I'm talking about. So we have 3 feet here. This side is equivalent to this side, which is also equivalent to this side, which is also equivalent to that side, okay? Therefore, the angles are also the same. All these angles are the same. And if we have a right triangle with 2 similar angles, those angles obviously are split 90 in half, and you get 45 degree angles, okay? So all these angles are 45 degrees. And hence we can treat the vector components accordingly. Because there are 2 anchor points for the clothesline, one right here, and also you can this is not drawn perfectly, but you can kind of say that this is right here as well. We can assume that the horizontal components cancel each other out. And knowing how to do this comes with practice, okay? So it's not something that you're intuitively inclined to do right away. So these kind of just cancel each other out, okay? So now all we're concerned about is the vertical vector components due to gravity tugging down, okay? So if we know that the clothes themselves weigh 3 kilograms, then we know that the total weight of the clothing is going to be about 30 newtons, okay? And the reason why it's 30 newtons is because we're using 10 meters per second squared for the gravitational acceleration constant instead of 9.8 meters per second squared. And then 30 newtons should be equivalent to tension. That's like the vertical component. We'll call this T. And we'll also call this T over here. Remember, the tension is being split in half because we have 2 posts holding up the clothesline, okay? And the times the cosine of 45 degrees. And we're doing this twice because we're splitting the tension in half between these 2 posts, okay? All right, and you could have easily used the sine of 45 degrees. It kind of doesn't matter because the sine of 45 degrees and the cosine of 45 degrees are kind of sort of the same thing because we have an isosceles right triangle, okay? So this simplifies to 2t, the cosine of 45 degrees is equivalent to 30 newtons. And then when we get rid of 2 on both sides, this entire expression will simplify to t, the cosine of 45 degrees equals 15. So now in order to find tension, all we have to do is divide by the cosine of 45 degrees, okay? So t times the cosine of 45 degrees is going to be t times 1 over radical 2. And if we divide the left-hand side and the right-hand side by radical 2, 1 over radical 2, we're going to get 15 radical 2 as our final answer for the amount of tension. Don't forget our newtons, okay? So our final answer would be D. And again, knowing that the two horizontal components cancel out and don't necessarily contribute to tension is kind of sort of difficult to know without practicing these sort of problems or reading about tension in a theoretical sense. So yeah, this type of problem, I know there might be a lot of videos out there that assume you should know this and that. If they act like that, they're kind of sort of lying to you, because this takes a lot of practice to get a feel for this sort